Hi everyone, we are Syncotech team and our research topic is development of self-powered multifunctional piezoelectric device based on CNT sheet and zinc oxide nanorods. So our content is divided into 4 parts. First, introduction. Second, experimental and research method. Third, expected results. And final, conclusion. And Ion will talk about introduction.
Hi, I'm Ion, and I'm going to talk about our introduction. Our research is all about piezoelectric sensor, and then do you know what it is? As you can see in this picture, if you give pressure, the voltage comes out. In reality, there is a piezoelectric energy floor on the subway in Tokyo, and this is kind of energy harvesting. Moreover, there are lots of sources to make energy harvesting, including piezo. From this energy harvesting, we can recycle energy. These are piezoelectric materials market graph and energy harvesting system market graph. As you can see from this left side graph, this graph is about piezoelectric materials, and piezoelectric materials market is getting higher every year. Likewise, the energy harvesting system market is getting better. We decided to follow these trends and to combine these two topics. In short, we're going to make an energy harvesting sensor with piezoelectricity. Unfortunately, most existing energy harvesting are from nature, like solar energy. They depend on weather conditions. For example, if it is rainy or cloudy, we can't harvest solar energy that day. Otherwise, our sensor will work not by nature, but by pressure from humans. Our sensor have a great advantage of not being affected by the weather.
So chapter 2, experimental and research method. So now I'm going to talk about why we choose this material. So you can just on this picture, to make a voltage, we need the pressure. So when we push left and right, the red dot goes down and black dot goes up. Red dot makes a positive voltage plus, and black dot makes negative voltage minus. And however, when you pull left and right, it makes the opposite voltage. In figure 2, in zinc oxide structure, this is root-like structure. So the center axis is not in the right center, so it can make a piezo effect. Next, how do we make? So we make a zinc oxide seed layer by jewel gel and spin coating, and the zinc oxide nanorod with hydrothermal, and the PDMS with spin coating, and the CNT sheet with PDMS by spin coating. We have 5 goals to achieve. So minimum voltage must be more than 100 millivolts, and the nanorod length must be more than 1 micrometer. And the PDMS thickness is less than 4 micrometer, and the exerted peak on 002 plane, the C plane, is more than 10,000, and the aspect ratio is more than 2.3.
Hi, I'm Jimin. I will talk about the research method. Number 1, seed layer process. First, we make seed layer solution by jewel gel and spin coating on the substrate. Second, spin coat seed solution to deposit uniformity and thinning. Third, to make sample crystallinity much better, we do soft bake and hard bake. If the hard bake temperature isn't high enough, the crystallinity didn't grow well. Number 2, the hydrothermal process. First, making hydrothermal solution, we mix zinc nitride powder and hexamethylene tetraamine with 1:4 ratio. Second, stir with the magnetic bar in the hot plate for 1 hour. Third, put the sample with the seed layer in solutions. Seal the beaker and put it in the oven for 6 to 12 hours. Then the nanorod will grow. Number 3, PDMS coating process. First, mix elastomer and cross-linker with 10:1 ratio and remove the bubble. Second, we use a spin coater to spread uniformity. Third, to erase the stickiness, bake on the hot plate for 7 minutes. Final is the CNT seat and PDMS process. First, we use the upper electrode using a CNT seat. This CNT seat came out from CNT forest, has very good conductivity because it is grown vertically. Second, put the CNT seat on the pre-PDMS and then spread another PDMS to protect our device.
Hi, my name is An Hee-jun and I'm going to talk about expected result part. We measured it based on fabricated sample. So this is our testing mechanism. First, we scratch the sample a little bit and then we coated a little amount of silver paste on there. And then we put in a voltage of 10 millivoltage to 200 millivoltage through the Arduino board. Next, when we press down the samples, we can get small signals. So we use the AMP amplifier for measurements. The reason why we use the AMP is to amplify tiny signals from zinc oxide nanowires. As a result, we can gain 3.4 voltage to 10 voltage by amplifying the circuit. Next, we made a simple LED circuit. Let me play a short video on how it works. We have not measured the exact external force yet, but we checked it that the amount of voltage increased much more. So the piezoelectric effect from zinc oxide nanowires can apply to various things like instruments, motor games, shooting games by programming Redbuild and Arduino. And this is our schedules. So these days we are collecting and analyzing data and making sensors.
Final conclusion. So we make a piezoelectric sensor and test whether it is good or not. So the test is good. Our final goal is making a piezoelectric energy harvesting system. So you can see on this picture, the pressure is made by human motion to vehicle vibration and building and bridge oscillation. For this pressure, we can make a conditioning monitoring or power shoes or pacemaker or tire condition monitoring. So this is make a green energy, and this green energy will help our earth more clean. So our presentation is finished, and I will introduce our team member. I'm the leader of this team, and Hee-jun, Jimin, Ho-sung, and Ayeon. Ho-sung is our team member, but he is now on COVID-19, so he can't join us. Thank you for your watching.